In this example, we are told that we are selecting several items without replacement, meaning that we're not returning the item after we select it. And the entire batch is accepted if every item in the sample is okay. We also were told that we have 8,834 total cases of malfunctions, and out of those, 504 were found to be caused by firmware, which is software programmed into the device. So if we test the firmware in 3 different pacemakers randomly selected from this batch of 8,834, so we're selecting 3, and so whenever you're selecting more than one, you need to have a probability for each individual item. So I'm going to have a probability of selecting the first, a probability of selecting the second, and a probability of selecting the third. And then with consecutive selections, you multiply these probabilities together. So to set up the probabilities, I have to always look at the part out of the total. We know that the total pacemakers is 8,834. So then I need to look at what I'm selecting. When we're trying to find the probability that the firmware will be accepted. So if it's accepted, then the entire batch works. And so we need to look at that positive amount. We're told that we have 504 had defects from the firmware. So if 504 are defective firmware, then I need to know the total that work, that don't have the defective firmware. So I need to subtract 8,330, which is the total pacemakers, 8,834 minus the number of defective ones, and then this will give me the opposite amount, which is the number that works. So this is 8,330 that aren't defective. So now when I set this up, the probability that the first pacemaker works, well, there's 8,330 that work out of 8,834 total. So you always do part over total. This is the probability that the first pacemaker works. Now I'm selecting that and not returning it. So the second probability has to take into account that your totals are changing. So instead of having 8,834 work that are total, I now have 8,833. And then the number of working pacemakers also changes from 8,330 to 8,329. So this is my second selection. And they tell us that we're selecting 3, and we want to find the probability that all 3 work. So then I need to change my totals once more to 8,328 working out of a total 8,832. So to calculate this, type this in your calculator in one step using the division button. So you'll do 8,330 divided by 8,834 times 8,329 divided by 8,833 times 8,328 divided by 8,832, and then press equals at the end, and this will give you the result of 0.838. And we typically round to 3 places when calculating a probability. So that would be the probability that the firmware in the entire batch is accepted, or we have a 83.8% chance that it's accepted. That's if all 3 work. So does that procedure suggest that the entire batch would consist of good pacemakers? Because we have a pretty high probability that we would accept the whole thing if we select 3. And the answer is no. We're told that the entire batch does have pacemakers that do not work for some reason. And so in this example, we were asked to find the probability that when we selected 3 random pacemakers, the firmware would work. but this is just one possible defect out of the entire batch. So this probability doesn't extend to all of them. We know some of them don't work, but we've just proven that by chance, we have an 83.8% chance of selecting 3 that do work.